Okay, so welcome to today's SQL lab. In this lab, we're going to build on the work that we previously did, learning how to select and filter records, how to group records, to generate summary statistics using functions. Today, we're going to go a little bit further by learning a new function in SQL, but something we've done previously in SQL, and that's if functions. But first, we're going to learn how to make the output of the summary tables we generate after we group records and calculate some summary statistics a little more useful by learning how to use a new clause called having, which will allow us to do some filtering. So in this lab, we're going to be using a single table database of campaign contributions to Larry Hogan and Ben Jealous in Maryland's governor's race. And this data is January 2014 through 2018. Just ahead of a primary election. Here, you can see the full documentation on the repo. At the end of this assignment, you're going to follow along with the exercise. You're going to write some queries, and then you're going to submit it to ELMS. So we've saved the file as 13 in-class lab, first name, last name, .sql. Put a comment with your name at the top of the file. Just as previously, if you haven't run this previously, we're setting SQL mode to full group by. And then let's just go ahead and look at the exercise .mdgovrace table here. Sort of something new. If we only want to look at the first 100 records to get a sense of the fields, we can end it with limit 100 or 1,000. This table has 55,000 records, so it might take a second to return if you select the entire thing. So I'm going to run that. We get the first 1,000 records, and remember, each row is a single contribution to a candidate during a given filing period on a given date by a person who has an address, the type of contribution, who they were, individual or a business. In some cases, we have information about who they worked for. We always have the amount for the most part. So just as a way of getting started here, I want to run a query that uses group by and some summary functions to build a nice little summary table that will break down all contributions by contributor type. So I'm just going to run that, and then we're going to walk through as a refresher what this does. So just going to write a comment here saying calculating summary statistics for contributor type to all candidates. Okay, and I'm going to turn on the wrap. So we're selecting the contributor type, which is individual or business or something else, the sum of contribution amount for that type, the average contribution amount, the smallest and largest contribution amount, and then the count, star, of the number of contributions. From the exercises governor's race table, we're going to group by contributor type, and then we're going to order it from largest to smallest on contribution total. So I'm just going to run that. And we get a table here that has one row per contributor type, and there's 13. With contribution total all the way from 10 million from individuals down to 6 from unknown anonymous, or 1,000 for nonprofit organizations. We get the average contribution, smallest and largest, and the number of contributions. Okay, so that's an example of a summary table. And then let's say we wanted to only look at the same table, generate these same statistics, but instead we want to only look at 2018 contributions. This table that we have right now is 2014 to 2018. So we're going to calculate summary stats for contributor type to all candidates in 2018. Okay, so I'm going to copy that same query, but in this case, I'm going to throw in a where clause And the where clause, which is going to go after the from, is going to limit contribution dates only to 2018. So we're only getting 2018 records. So when we did all of it, we had 10 million in contributions to individuals. I'm going to run this query. And now we get a smaller amount. So we have this individual contribution total of about 2.6 million, all the way down to unregistered, out-of-state, non-federal committee at 250. We get a total of 12 records that were returned. But let's say that we would prefer to have a table returned here that only examined the more meaningful contribution categories. And in this case, we'll define more meaningful as having a contribution total in 2018 greater than 10,000. So we can do that, and to do that we can use a new kind of filter that works exclusively on these summary tables that are generated after a group by query called having. So I'm going to modify this query to say calculate summary stats for contributor type to all candidates in 2018, but only return those types with a contribution total above 10,000. Okay, so I'm going to paste that query in, and the only difference is I'm going to add this one line having, and we're going to put it after the group by. So we're saying having a contribution total greater than 10,000. Okay, so we haven't run the query yet, but right now we have a total of 12 records, and we have these 4 here: registered out-of-state non-federal at 4,000, political club at 2,100, nonprofit org at 1,061, unregistered out-of-state non-federal committee at 250. Okay, I'm going to execute this query, and now we get 8 records, and those 4 that have a contribution total under 10,000 are now missing. Okay, so just a note here, order matters. So when we're filtering with where, it goes before the group by. When we are filtering with having, it must go after the group by. Okay, so why is this? Well, that's because the where clause, the filtering from the where clause, happens in the original table. It takes out all records that aren't 2018 before we do any sort of summary calculations. Whereas the having, behind the scenes in the computer, it is only executing after this table is built, and then the last thing it's doing right before it sorts is to strip out these 4 records. Other than that, the having filter works a lot like the where filter, and we can do a lot of the same things with the where filter, having filter that we can do with the where filter. So this includes using multiple filters. So we could say having a contribution total greater than 10,000 and average contribution greater than 200. And in that case, if we execute this query, it will strip out the individual contribution. See, that's gone. We can also use like operators, and in fact, we can even filter non-computed columns. So both of the things we've filtered on so far were things that were created by functions we wrote. So the contribution total was from a sum function. The average contribution was from an average function. But we can filter out on something as basic as contributor type, which is a non-computed column. So, and contributor type like committee, so this is going to return only those records that have the word committee in it when we run it. Okay, so that is the having clause. Now let's suppose that we want to examine how the money coming from different contributor types, and so that's what we've been looking at here, individuals, PACs, businesses, differ for each candidate. So we could create a nice little summary table with a query like this, and I'm going to run it, and then we'll look at it. Okay, so here's what we're doing. We're selecting the receiving committee, which is a stand-in for the candidate name. We're selecting individual contributor types, so individuals, business. We're selecting the sum of contribution amount as total contribution amount. And then we're counting the number of records from exercises.mdgovrace. And then we're grouping by receiving committee, and then we're grouping by contributor type, which is why in this case we get individual contributor type totals for Hogan, and then down here we get individual contributor type totals for Jealous. And then we are sorting by the receiving committee, so we group together all the Larry Hogan stuff and all the Jealous stuff, and then we're sorting by total contribution amount. So within that we get a list of what the most important contributor types were to both candidates. In this case, both to Hogan and to Jealous. It was individuals followed by business group and organizations. Okay, so now let's suppose that we wanted to benchmark the results that we're seeing here against the total contribution amounts to each candidate. So, for example, this might be useful down the road if we wanted to be able to say what percentage of Larry Hogan's total contributions came from individuals, or what percentage of Ben Jealous's total contributions came from businesses. Well, we could, to get those figures, run a similar query as the query above. So we've got our sort of individual breakdown here. And then we could run the totals for Hogan and Jealous. So I'm just going to make a comment here first to note this is contributor type totals by candidate. This is totals by candidate. Okay. And we get total contributions to Hogan and Jealous, along with the number of records, which we could later use to benchmark. Would require a lot of copying and pasting on our part. And then let's say we wanted to, sort of get the overall total. So like combine these two things together. We could do a much simpler query, which would look like this. Okay, so we have one table. I'm going to execute this again, where we are selecting the receiving committee and the contributor type and calculating totals. So we've got a breakdown of contributors, contributor amount, and number of records for each contributor type by each candidate. And then separately, we've calculated an overall total for each candidate. And then we've created overall totals for everybody. Okay, so that's a lot of queries, but there is a really nice little trick with SQL that we can use to automatically calculate all of that information in a single table. And the key term here is called with rollup. So let's run our original query one more time, just so we have got it to compare here. So I've got a contributor type totals by candidate. So remember, we've got Hogan, each contributor type, and totals. Jealous, each contributor type, totals. So here we have 18 rows. There's 9 for Jealous, 9 for Hogan. I'm going to drop a new query in here, and this is using the with rollup clause. And we're going to call this contributor type totals by candidate with rollup. Okay. And then let's execute this. We get an error. Okay, so I'm just going to control right click here. I'm going to copy the row. Sorry, going to copy the response. Going to paste that in. Error code 1221, incorrect usage of cube, rollup, and order by. Okay, so why are we getting this? Well, unfortunately, when we use the with rollup, which is going to do some automatic sort of subtotal and totaling for us, we cannot use order by. It's just a quirk of SQL, but unfortunately it's something we're going to have to eliminate. So I'm going to put my semicolon at the end of with rollup, and I'm going to delete the order by, and then we're going to run it one more time. Okay, so what do we get here? We get a total of 21 records, right? Before we had 18. We had 9 for Hogan and 9 for Jealous. So we have 3 extra rows. So the 3 extra rows are this one, where you have Hogan, Larry for governor, and then null, and then some totals. Jealous, Ben, friends of, null, and some totals. And then a double null, and some more totals. Okay, so here's what we're looking at, and here's what rollup does for us. So this row here, Hogan, Larry for governor, total contribution amount is about 14 million. It has taken all of these rows here in total contribution amount and added those up to equal that. Same with number of records. It has added up all of the contribution types to give us a total for Hogan. And we see the same thing with Jealous. So the total of all of these contributor types for Jealous is 2.26. Total of 19,000 and change contributions. Okay. And then at the very bottom, this row, null and null, is the sum of this total for Hogan, this total for Jealous equals that. Same with this. This total for Hogan for number of records plus this total for Jealous gives us that. Okay, so this is a nice way to do these kinds of subtotaling and totaling contribution. It gives you some sort of more meaningful results. I want to show you one little quirk of with rollup. In addition to the not being able to use order by, there's also some weirdness that comes in when you use it with having that I want to go over. So just so we can see these in front of us, I'm going to paste in the totals we got for Hogan, for Jealous, and for the overall total. Okay, so pay attention to those numbers. Okay, so I'm going to rerun this rollup query, the same thing we have here that gave us this nice little table of contributor type by candidate and totals. The only difference is this time I'm going to put in a having clause where the total contribution amount is above 50,000. So if we remember back to having, that's going to eliminate things like this $6 unknown anonymous for Hogan, or this 12,000 political club for Hogan, or the $50 that Jealous got from a candidate committee. So we're going to have a much smaller table here, so I'm just going to run that. Okay, so we've got 3 for Jealous, or sorry, 2 for Jealous, and 6 for Hogan. And then we still have our 3 roll-up, created rows. So the total for Hogan, the total for Jealous, and the overall total. Okay. So, and again, remember, I've limited it to things above 50,000. All right, so I want you to pay attention here to the total for Larry Hogan. So it is $14.12 million is the total contribution amount. Does that look familiar? It should, because it's the same amount that we got when we did the roll-up calculation without the halving clause, this one up here. What about for Jealous? We get 2.26 million. Same with this one, right? It's the same exact figure. And in terms of number of contributions, this is the same, 19,689, Hogan 35,638, Hogan 35,638, and the overall total is 16,000,000.39, and the number of records is 55. Okay, so here's the thing. We've used halving to remove the rows here that didn't meet the criteria of being greater than 50,000. But the roll-up happened before that halving clause executed. So if you are thinking that if you use a halving clause, that these totals that we see here are just a summation of the records that were returned, that's not the case. You have to be really careful about interpreting the results when you combine halving and roll-up. Okay, so that's halving, and then with roll-up. Now I just want to take a minute to talk about if functions. So we've used quite a number of functions so far in our work with Excel. We've used things like count and sum and min and max. We've used year, month, truncate. There's lots of different functions that we can use. And there's one that is kind of particularly useful, and we've done it in Excel. I just want to go over how it's going to work here. So an if function is generally structured like this, and it's going to be the same in SQL as it is in Excel. So if a contribution amount, in this case we're going to be looking at total contributions, or a contribution amount to Hogan and Jealous is greater than 5,000, we're going to create a new column, and in that new column we're going to call such a contribution a large contribution. If not, if it's under 5,000, it's anything else, we'll call it a small contribution. So let's take a look at how this might work. So I am going to so in this case, I'm going to create a take our original table of contributions, but I'm going to add on to the end a new column called contribution size. And we're going to classify the contribution level as either large or small. So I'm just going to paste that in here. New column for classifying contribution size. So we're going to select star, so select every single row, every single column. We're going to select the contribution amount again, and if the contribution amount is greater than 5,000, in this new row we're creating called contribution size, call it a large contribution. If not, call it a small contribution from exercises.mdgovrace. And we're going to run it. And so at the end here, we've got the contribution amount, which is really just this row repeated. And then if it's under $5,000, we call it a small contribution. If it's greater than 5,000, we're going to call it a large contribution. So here's an example of a $6,000 contribution. It's large. Here's a $100 contribution, and it is small. And then we can create. We can also use the if function to create to create summary statistics. So going to count number of contributions, large and small, and I'm going to paste this in. So here's what we're doing. We're creating a new column called contribution size. So select if the contribution is greater than 5,000, call it large, otherwise call it small. And then we're going to count the number of records in one field, call it number of records, and then a sum of the contribution amount is total contribution amount. So adding up all the large and small contributions from exercises.md gov race, and then group by contribution size. So that's this new column we're creating. And we can see that what we have classified, there were 421 large contributions and 54,000 small contributions. If you remember back to Excel, we can also do what's called nesting if statements. Let's suppose we wanted to chunk our contribution classification as either large, small, or tiny. In this case, anything under 1,000 would be small, tiny. Anything over 5,000 would be large, and everything else would be small. So here's an example of a nested if statement. So 3 categories of contribution size: totals, tiny, small, and large. So select if the contribution amount is over 5,000, calling it a large contribution. But instead of putting small contribution here, we're putting a new if statement. So we say if the contribution amount is greater than or equal to 1,000, call it a small contribution. Otherwise, a tiny contribution. This parenthesis closes this parenthesis. This parenthesis closes this parenthesis. Then we call that column contribution size. We do a count and we do a sum, total of 3 columns. Here's where we're selecting from. And then we're grouping by contribution size. And now we get 3 rows: large, small, and tiny. And most of the contributions in this race were under $1,000. Okay, that's it for today's lab. Go ahead and save your work, and if there's time, go ahead and work on the homework and submit this file to ELMS.